Now start problem 37. Two spring of spring constant 500 Newton per meter and 300 Newton per meter respectively are stretched with same force. Force is same, only different in a K. X is not given. X is not given. Then without X formula we use U equal to F square by 2K. F is constant. Then U proportional to 1 by K. Then U1 by U2 equal to K2 by K1. 3000, 1500 cancel to 2 jam 1. Next, 38. A body is attached to the lower end of a vertical spiral spring and it is gradually lowered to its equilibrium position. This stretches the spring by length x. If the same body attached to the same spring is allowed to fall suddenly, what would be the maximum stretch in this case? Maximum stress find करना है initially. First, initially spring is in equilibrium. Load hanging with spring. This stretches the spring by the x. If the same body attached to the same spring is allowed to fall suddenly, what would be the maximum stretching in this case? Second, when spring is allowed to fall suddenly, it oscillates about its known position. Let we take y is the amplitude of the vibrational, then at lower extreme by the conservation of energy. So 1 upon 2 ky square is equal to mgy. Now y is equal to 2 mg by k, 2 mg by k. So now put value of x, mg by k is equal to 2x. So y equal to 2x. Y is equal to 2x. Next, two equal masses are attached to the two end of a spring. Of spring constant K. Two equal masses are attached to the two end of a spring of spring constant K. The masses are pulled out symmetrically to stretch the spring by a length x. Stretch the spring by the length x over its natural length. The work done by the spring on each case. So if spring is stretched by x, the work done is 1 upon 2 x square. Now, if the spring is stretched length x, then work done by two equal masses, 1 by 2 kx square. So work done by each mass each 1/4 और ½ में कन्वर्ट होगा, डिवाइड बाई 2, 1/4 kx square. Work done by the spring on each mass is -1/4 kx. दोनों में डिस्ट्रीब्यूट होता है. अब इलेक्ट्रिक पोटेंशियल एनर्जी, ट्वेल्थ में आता है, लेकिन हम यह स्टडी ले लेंगे केसेस, सब 12th वाले इसलिए. तुम्हें मालूम है चैप्टर 2 12th में इलेक्ट्रिक पोटेंशियल एनर्जी K Q1 Q2 by, this is the formula, is K Q by R is equal to V. Also we write E equal to Q into V. As charge can positive or negative, तो electric potential energy can be positive or negative. तो 12th की इलेक्ट्रिक पोटेंशियल एनर्जी है वो यहाँ देखेंगे, उसके सम भी है, सम प्रॉब्लम. A proton has a positive charge if two protons are brought near to one another. The potential energy of the system will be near to, means proton same charge towards this direction, towards the direction, means repulsion increase. Repulsion increase means potential energy increase, kinetic energy decrease, the potential of the system increase. Two protons are situated at a distance of 100 Fermi from each other. So 100 Fermi, 100 into 10 raised to -15 meter. The potential energy of the system proton. So K Q1 Q2 by K is equal to 9 into 10 raised to 9. Q proton charge on a proton 1.6 into 10 raised to -19 Q into Q square. R is equal to 100 into 10 raised to -15. So answer is 2.304 into 10 raised to -15 joule. Now convert in electron volt. So divide by 1.6 into 10 raised to -19 electron volt. So 1.44 into 10 raised to 4 electron volt. Hg208 nucleus is bombarded by alpha particle with velocity 10 raised to 7 meter per second. If the alpha particle is approaching the Hg nucleus head on, then the distance of closest approach. तो यहाँ पर Hg है और अल्फा पार्टिकल यहाँ से आता है, तो यहाँ तक आते हैं, वहां से रिटर्न होता है, तो दिस डिस्टेंस फाइंड करना है. तो इनिशियली have a kinetic energy 1/2 mg square. In this distance, potential energy K Q1 Q2 by R या D. So 1/2 mv square 1/2 1.6 into 10 raised to -27 10 raised to 7 whole square is equal to 9 into 10 raised to 9. 2e अल्फा का चार्ज है 2e और Hg का चार्ज है 80e by R. 10 raised to 7 square, but this is the mass of the proton. So mass of the alpha particle is 2m. M alpha equal to 2m है. So into also we write in 2 into mass of the alpha proton. Okay, the 2 है mass of the proton है, उससे twice है alpha, because 2 proton in alpha particle. Sorry, 4m आएगा, because 2He4 है, 2He4. The mass of the alpha particle is 4m. So here we write into 4. Okay, जो आंसर आएगा वो ही हमें लेना है इसमें. तो R हमें मिलता है यहाँ पर. charged particle A move directly toward another charged particle B. For the A plus B system, the total momentum is P and the total energy is E. So all have a total energy and momentum are conserved. So if A and B are free to move, no external force are acting, hence P and E both are conserved. But B is fixed, then only E is conserved, but momentum is not conserved. फिक्स बी फिक्स रहेगा तो मोमेंटम कंजर्व नहीं रहेगा, ओनली एनर्जी इज कंजर्व। ये हमें याद रखना है। फ्री रोटेट टू मूव फ्री, देन ए एंड बी के लिए एनर्जी और मोमेंटम बोथ कंजर्व, बट बी इज फिक्स, देन ओनली ई इज कंजर्व, मोमेंटम इज नॉट कंजर्व। ग्रेविटेशनल पोटेंशियल एनर्जी चैप्टर 7 में आता है। तो यहाँ पर पोटेंशियल एनर्जी इन इलेक्ट्रिक फील्ड वी टेक U इक्वल टू K Q1 Q2 by R. Gravitational potential energy take K replace G. G Q means M, G M1 M2 by R. Here we take minus because gravitational force is attractive force, then we take a minus. If a body of mass M at height h relative to the surface of the earth, the gravitational potential energy is in the form of h G. So U is equal to mgh upon 1 plus h upon r. चैप्टर 7 में लेंगे, यहाँ पर ओनली लर्न करेंगे, याद रखेंगे mgh upon 1 plus h by r. If h very less than r, then h very less than r, this term is negligible, then U equal to mgh. If V is the gravitational potential, at a point, the potential energy of the particle of mass M, at that point, we take U equal to mv. In electric potential energy, we take Q into V. Here V is electric potential, here V is the gravitational potential. Energy height graph. When a body projected vertically upward from the ground level with some initial velocity, then it possesses kinetic energy, but its potential energy is 0. At maximum height, kinetic energy is 0 and potential energy maximum. At bottom, kinetic energy maximum and potential energy is 0, but total energy is constant. So at bottom, kinetic energy maximum, potential 0. Height increase, then kinetic energy decrease, potential energy increase. At maximum height, potential energy maximum, kinetic energy is 0. ये हमें याद रखना है, ओके? तो ये पोटेंशियल एनर्जी की टर्म थी सब। अब इसके रिगार्डिंग सम देखते हो, सम एग्जाम्पल। The work done in pulling up a block of wooden weight 2 kilonewton. Mass given 2 kilonewton. So M is equal to 2 into 10 raised to 3 Newton given. For a length of 10 meter. Length है इसकी 10 मीटर है, स्लोप की लेंथ L इक्वल टू 10 मीटर। on a smooth plane inclined at an angle 15 degree with horizontal is कितना वर्क, तो यहाँ तक एनर्जी है पोटेंशियल जीरो, यहाँ तक जाना है तो यहाँ पोटेंशियल जीरो, तो चेंज इन पोटेंशियल एनर्जी इट की वो वर्क, तो यहाँ पर पोटेंशियल एनर्जी है एम जी एच मीन्स साइन थीटा इज इक्वल टू opposite side upon hypotenuse and h equal to L sin theta. So now put h equal to L sin theta, mg, so mg total given weight 2 into 10 is to 3. So 2 into 10 is to 3, L given 10, sin 15 also given 0.259. So here 5176 joule means 5.17 kilojoule is the work done. Next. Two identical cylindrical vessels with their base at same level. Each contains a liquid of density D. The height of the liquid in one vessel is H1 and that is other vessel is H2. Height is here H1 and here H2. The area of either vessel is A, cross-section area is A, here A. Okay. The work done by the gravity in equalization, the levels when the two vessels are connected both vessel, then height is same. The work done chahiye to change in the potential energy. The potential energy of liquid column is given mgh by 2, m equal to density into volume, so density into volume, volume equal to area into height, A into h dgh h by 2. Okay, मीन्स एच है तो ये आएगा हमें लास्ट में पोटेंशियल एनर्जी 1/2 AdgH²। इनिशियल पोटेंशियल एनर्जी इसकी आएगी 1/2 AdgH1², इसकी आएगी 1/2 AdgH2²। फाइनल पोटेंशियल एनर्जी दोनों का एडिशन 1/2 AdgH², 1/2 AdgH², तो एडिशन तो AdgH²। The work done is equal to change in the potential energy, initial potential energy minus final potential energy. So AdgH common, so here write H1² by 2 plus H2² by 2 minus Adg. But here we take H is H1 average, H1 or H2 का average लेना है. So we take H is equal to H1 plus H2 by 2. So AdgH in bracket H1² by 2 plus H2² by 2 minus here H1² plus H2² plus 2H1 H2 by 4. Now calculate to Adg H1 minus H2² by 4. तो हमें याद रखना है तो is in a form of density and area. यहाँ तक रखते हैं, कल देखेंगे अब टुमारो सी सेम टाइम। ओके।